There are different methods for installing ground fault circuit interrupter, or GFCI, receptacles. Two common methods are using backwiring terminals and looping wires around screws. Each method has its own advantages and disadvantages. Backwiring terminals offer several benefits. Firstly, they are often faster and more convenient to use, especially for those with experience. Secondly, backwiring can handle multiple wires, simplifying the installation process in certain situations. However, there are also potential drawbacks to consider. Firstly, backwiring can be less secure if not done properly, leading to loose connections and potential hazards. Secondly, repeatedly using the backwiring method may weaken the wire over time. Looping wires around screws presents a different set of characteristics. Firstly, this method tends to provide a more secure connection compared to backwiring. Secondly, looping allows for accommodating different wire gauges, providing flexibility in various wiring scenarios. On the other hand, this approach can be more time-consuming. Firstly, it often requires more precision and attention to detail, especially in tight spaces. Secondly, looping wires around screws may be challenging for less experienced installers. The best method depends on several factors. Firstly, local electrical codes can dictate specific requirements for GFCI receptacle installations, so it's essential to be aware of and comply with these regulations. Secondly, the receptacle type itself may influence the choice, as some GFCI receptacles come with specific instructions or recommendations for wiring. Thirdly, the wire type and gauge play a crucial role in determining the appropriate method. Different wire types, such as solid or stranded, and varying gauges may necessitate different wiring techniques. Fourthly, the skill level of the installer should be taken into account. Looping wires around screws demands a higher level of expertise and dexterity, while backwiring might be more accessible for beginners. Generally, for thick solid wires, such as 12 American wire gauge or AUG, or larger, looping the wires around the screws is often the preferred method due to the increased security and durability it provides. For thin solid wires, like 14 AWG or smaller, backwiring the terminals can be a viable option, but only if the receptacle is specifically designed and approved for this purpose. For stranded wires, it's generally recommended to use wire nuts to connect the wires to the terminals. Wire nuts create a secure and reliable connection for stranded wires, minimizing the risk of loose strands or poor contact. To ensure a safe and reliable GFCI receptacle installation, keep these tips in mind. Firstly, always use a torque screwdriver to tighten the screws to the manufacturer's specified torque. This ensures that the wires are securely fastened and minimizes the risk of loose connections. Secondly, regularly inspect the wires and connections for any signs of damage or looseness. Loose or damaged wires can create a fire hazard, so it's important to address any issues promptly. If there is any doubt about the proper installation procedure or compliance with local codes, it is always best to consult with a qualified electrician. Electricians have the knowledge and experience to ensure that the GFCI receptacle is installed safely and correctly, minimizing the risk of electrical hazards. The National Electrical Code, or NEC, provides comprehensive guidelines and requirements for electrical installations, including GFCI receptacles. Understanding and adhering to the relevant NEC articles and sections is crucial for ensuring electrical safety. Some relevant NEC articles and sections include Article 210.8, which covers ground fault circuit interrupter protection for personnel, and Article 406.4, which addresses the installation of receptacles. Always refer to the latest edition of the NEC and consult with a qualified electrician for specific requirements in your area. Ground fault circuit interrupter receptacles are designed to protect people from electrical shock. They work by monitoring the current flowing through a circuit. If there is a difference of 5 mA or 0.5 amps or more between the outgoing and returning current, the GFCI will trip and cut off the power to the circuit. This can happen if someone touches a live wire or if there is a ground fault, which is a short circuit between a live wire and ground. GFCI receptacles are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. They can also be used in other areas of the home, such as bedrooms and living rooms. There are two main types of GFCI receptacles: feed-through and non-feed-through. Feed-through GFCI receptacles protect both the receptacle itself and any downstream receptacles or devices on the same circuit. Non-feed-through GFCI receptacles only protect the receptacle itself. When installing a GFCI receptacle, it is important to follow the manufacturer's instructions carefully. The first step is to turn off the power to the circuit at the breaker box. Then, remove the old receptacle and disconnect the wires. Connect the wires to the new GFCI receptacle according to the manufacturer's instructions. Be sure to connect the ground wire to the green ground screw. Once the wires are connected, carefully push the GFCI receptacle into the electrical box and screw it in place. Finally, turn the power back on at the breaker box and test the GFCI receptacle to make sure it is working properly. To test a GFCI receptacle, press the test button. The receptacle should trip and cut off the power to the circuit. Then press the reset button to restore power to the circuit. If the GFCI receptacle does not trip when you press the test button, or if it trips repeatedly for no apparent reason, there may be a problem with the receptacle or the circuit. In this case, it is important to consult with a qualified electrician. In addition to GFCI receptacles, there are also GFCI circuit breakers. GFCI circuit breakers protect the entire circuit rather than just a single receptacle. They are typically used in situations where it is not practical to install GFCI receptacles, such as on circuits that serve multiple rooms. When choosing a GFCI receptacle or circuit breaker, it is important to select one that is rated for the appropriate voltage and amperage. GFCI receptacles are typically rated for 120 volts and 15 amps or 20 amps. GFCI circuit breakers are available in a variety of voltage and amperage ratings. It is also important to choose a GFCI receptacle or circuit breaker that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. This ensures that the product has been tested and meets safety standards. The cost of GFCI receptacles and circuit breakers can vary depending on the brand, type, and features. However, they are a relatively inexpensive way to protect yourself and your family from electrical shock. Here are some additional tips for working with electrical wiring. Firstly, always turn off the power to the circuit at the breaker box before working on any electrical wiring. Secondly, use the correct tools for the job. Thirdly, never work on electrical wiring when you are wet or standing in water. Fourthly, if you are not comfortable working on electrical wiring, consult with a qualified electrician. Electricity can be dangerous, so it is important to take precautions when working with it. By following these tips, you can help protect yourself from electrical shock. When working with electrical wiring, it is important to understand the different types of wires. The most common types of wires are copper and aluminum. Copper wires are more conductive than aluminum wires, but they are also more expensive. Aluminum wires are less expensive than copper wires, but they are also more prone to corrosion. Wires are also classified by their gauge, which is a measure of their thickness. The lower the gauge number, the thicker the wire. For example, a 12 AWG wire is thicker than a 14 AWG wire. The appropriate wire gauge for a particular application depends on the amount of current that the wire will be carrying. The NEC provides guidelines for the minimum wire gauge that is required for different applications. When connecting wires, it is important to use the correct type of connector. There are many different types of wire connectors available, such as wire nuts, crimp connectors, and push-in connectors. The type of connector that you use will depend on the type of wires that you are connecting and the application. It is also important to make sure that the wire connections are secure. Loose wire connections can cause electrical problems such as flickering lights, blown fuses, and even fires. When installing electrical wiring, it is important to follow all applicable electrical codes. Electrical codes are designed to protect people and property from electrical hazards. Electrical codes vary from location to location, so it is important to check with your local building department to find out what codes apply in your area. If you are not familiar with electrical codes, it is best to consult with a qualified electrician. GFCI receptacles are an important safety device that can help protect you and your family from electrical shock. By understanding how GFCI receptacles work and how to install them properly, you can help ensure the safety of your home. Firstly, ensure the power is off. Secondly, carefully remove the faceplate. Thirdly, test the circuit with the non-contact voltage tester. Fourthly, identify the wires. Fifthly, disconnect the old receptacle. Sixthly, connect the new GFCI receptacle. Seventhly, gently fold the wires into the box. Eighthly, secure the GFCI receptacle with screws. Ninthly, attach the faceplate. Tenthly, test the GFCI receptacle. These steps are the basics. The specific steps may vary slightly depending on the manufacturer's instructions. Always refer to the manufacturer's instructions for the specific GFCI receptacle you are installing. When working with electrical wiring, it's crucial to prioritize safety above all else. Always disconnect the power supply at the circuit breaker before commencing any work on electrical circuits or devices. This simple step can prevent electric shock and potential injury. Before touching any wires, utilize a non-contact voltage tester to verify that the power is indeed turned off. These testers emit an audible or visual signal when voltage is detected, providing an extra layer of safety. When connecting wires, ensure that you are using the appropriate wire connectors designed for the wire gauge and type. Wire connectors, such as wire nuts or push-in connectors, create secure and reliable connections, minimizing the risk of loose wires or arcing. When tightening wire connectors, apply the proper amount of torque as specified by the manufacturer. Over-tightening can damage the wires, while under-tightening can result in loose connections. A torque screwdriver can help you achieve the correct torque setting. When working in electrical boxes, make sure there is sufficient space to accommodate the wires and devices. Cramped conditions can lead to damaged wires and difficulty making connections. If the box is too small, consider replacing it with a larger one. Regularly inspect electrical wiring and devices for any signs of damage, such as frayed insulation, cracked outlets, or loose connections. Damaged wiring can pose a fire hazard and should be repaired or replaced promptly. When working with electrical circuits, always follow the guidelines and requirements outlined in the NEC. The NEC provides comprehensive standards for safe electrical installations, covering topics such as wiring methods, grounding, and overcurrent protection. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Electricians have the training and experience to safely and correctly install and repair electrical systems. When working with ground fault circuit interrupter devices, understand their purpose and function. GFCI devices protect against electrical shock by monitoring the current flowing through a circuit and tripping when a ground fault is detected. Test GFCI devices regularly to ensure they are functioning properly. Press the test button on the GFCI device. This should cause the device to trip and interrupt the power supply. If the device does not trip, it may be faulty and should be replaced. When replacing a GFCI device, ensure that the replacement device has the same voltage and amperage rating as the original. Using a device with an incorrect rating can damage the circuit or pose a safety hazard. When wiring a GFCI device, follow the manufacturer's instructions carefully. Incorrect wiring can render the device ineffective or create a dangerous situation. Pay close attention to the line and load terminals on the device. The line terminals connect to the power supply, while the load terminals connect to the downstream circuit. When installing GFCI protection, consider the specific requirements of the location. The NEC requires GFCI protection in certain areas, such as bathrooms, kitchens, and outdoor locations. When using extension cords, choose cords that are rated for the intended use and are in good condition. Damaged extension cords can pose a fire hazard. Avoid overloading electrical circuits. Overloading can cause the circuit breaker to trip or, in extreme cases, start a fire. Do not run extension cords under rugs or carpets. This can trap heat and cause the cord to overheat. Keep electrical cords away from water. Water can conduct electricity and create a shock hazard. Use caution when working near power lines. Maintain a safe distance from power lines to avoid electrocution. If you see a downed power line, do not approach it. Contact the power company immediately. Be aware of the signs of electrical problems, such as flickering lights, burning smells, or sparking outlets. If you notice any of these signs, investigate the cause and take corrective action. Install smoke detectors and carbon monoxide detectors in your home. These devices can alert you to potential hazards and save lives. Have your home's electrical system inspected periodically by a qualified electrician. Regular inspections can help identify potential problems before they become serious. By following these safety precautions, you can minimize the risk of electrical hazards and protect yourself and your family.